in target 9b. When you're doing these, there's two answers to the problem. I think you're going to be okay with the number of terms. We've been doing okay with that. But they're separated by minus or plus signs. So this is a monomial, 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 but three of them makes a trinomial. So this one is going to be a trinomial. So I'm actually going to go through and name all those first. So looking on this one, we have two terms. And the term we use for that is binomial. One term, yes, there's an x and a y, but there's no plus or minus. So that one we would call a monomial. And then this one here has 1, 2, 3, 4 terms. Nothing goes together. We have a fancy name. It's called a 4-term polynomial. And if there's any more than that, we just call it by the number of terms. I know, very creative. But anyways, now back to the degree. The degree is very simply the highest power on the exponent, okay? So if we only have like this x cubed, x squared, and no x's, we literally go by the 3, and the degree of that polynomial is known as 3. It's called cubic. It's the third degree. Here, same idea. The degree is the highest power on the variable, so we say it's 4. And then over here you'd say, oh, it's 6, but be careful. If you have two different variables within the same term, you have to add those together and you actually get an 11. The degree on this one is actually equal to 11. Now, I do want to say one thing on this extension question. If this said like plus 2x squared y to the 7th, this would have another term with a degree of 9, because 7 plus 2 is 9. The degree would still be 11 because that's the highest one. We don't add them all together is what I'm getting at. If this was a minus 10 y to the 12th power, well, now we have a degree of 12 because that's the highest power we have. Okay, so hopefully that made some sort of sense. On this last one, there's only one variable that we see, one type of variable. Highest power is 5. Degree on this one would be 5. Okay, so you can get that down. All right, starting to transition into the other problems here. Now, what I'll do is I'll probably just do a few of them, but the big kicker here is that they're all mixed together. Okay, so just looking here, you have addition, you have subtraction, you have multiplication, then eventually we'll get to division, but they're all mixed together, and you got to know what you're doing at each time. So if I look at number 15, there's a plus sign in front of them, or in the middle of them. That's a trinomial plus a binomial. That's literally just combining like terms. You don't have to do this crazy distributing multiplication because that's not what's being asked of us here. So 5x squared minus 8x plus 4, and then you just literally add 2x minus 3. It's as if you drop the entire parentheses. Well, now we just combine like terms. I have no other x squared, so I'm good there. Negative 8x, positive 2x, just combine them. Don't add and make it 10, that doesn't make any sense, just combine them. I really have negative 6, and I leave the variables exponents the same. When I'm combining like term, nothing changes. And then we have plus 1 with the 4 and the negative 3, so that's the answer there. 16, same idea. So not to go into too much depth here, but basically you just can drop the parentheses because there's just a plus sign but between them. The only time it gets really, really tricky is when there's a minus sign that you have to bring through. So 8x squared, and that would be minus 2x, and then minus 3 when you combine those. All right, 17, pretty much like it, but you got to distribute first. So we're going to distribute through. 2 times 3x is 6x. 2 times a negative 8 is a negative 16. But now here's the kicker on this next part is that you have to distribute the negative with the problem. Okay, so the negative 6x is the entire thing that goes through. So negative 6x times x is negative 6x squared. Negative 6x times 5 is negative 30x. And then we combine like terms. And you can put these in any order. If you go left to right, we really have 6x's and negative 30. That combines to negative 24x minus 16 and minus 6x squared. That's the exact same thing as if somebody wrote negative 6x squared minus 24x and then minus 16, because you keep the signs the same in front of every term. As long as you do that, you are good. All right, next one, 18 is very similar to that one, so I'm going to skip that one. But as we move to the bottom of our paper here, these are FOIL problems. You use FOIL, not all the time, but you use FOIL when you're doing binomial times a binomial. So here we got the first, 4x times 4x, we got 16x squared. The outside here, 4x times 2y, positive times a positive is a positive 8xy. And then we have the inside, which is negative times a positive, so that's negative 12xy. And then finally the last here is negative 3 times positive 2, sorry, negative 3y times positive 2y, negative 6y squared. And again, we want to combine those like terms. So we got 16x squared. Don't change the exponent on them. I really have minus 4xy because I'm literally just combining like terms right now. Minus 6y squared. Okay, this one here is very similar to that problem. So I'm going to leave that one, but you can FOIL that problem and work that out just like that one. That's what the foiling process is.